Alright, so as an example of uploading a video to YouTube, I'm going to do one or two of the homework problems that Dr. Bai assigned. So the first one was, I think they actually start with number 9. So number 9 started with, it was x squared dy dx minus 2xy equals to 3. So ideally, to begin to solve a differential equation, we want to get into the form where it looks something like this. So let's kind of write down things we have to know on the side over here. So dy dx plus p of x y equals g of x. So this is kind of our general form for the differential equation. So in order to get this one looking like that, let's divide out by x squared to get dy dx by itself. So dividing this out by x squared, we end up with something that looks like this. dy dx minus 2xy over x squared equals 3 over x squared. So x is canceled, so we have dy dx minus 2y over x equals 3 over x squared. So from here, we can kind of see that the equation doesn't look separable. So it might be a good time to implement the integrating factor. So if you remember from the review, the integrating factor is some function mu of x that multiplies every term in the differential equation. So multiplying mu of x into everywhere in here, so we have mu of x times dy dx, mu of x p of x, y equals mu of x g of x. So so if you go through the proof, mu of x is actually defined as an exponential function of the integral of p of x dx. And then another kind of magic property of the integrating factor is that this term out here will just equal to mu of x p of x is just equal to mu prime of x, or the derivative of mu of x. So now that we kind of know this stuff here, we can go back to our differential equation and implement this. So first thing we have to do is determine what our mu of x is. And again, mu of x is the exponential function, so we have to identify in here what p of x is. So in this case, it's pretty obvious. So p of x is the function of x that multiplies y over here. So the function of x here is just p of x equals 2 minus 2 of over x. So to get mu of x, we had to take the exponential and the integral. So it equals to e integral of minus 2 over x dx. So taking that integral, so we can get mu of x equal to just 1 over x squared. So knowing mu of x is just 1 over x squared, we can take that term and multiply the rest of the differential equation where we have it looking like this. So mu of x multiplies out every factor. So out here we have 1 over x squared dy dx minus so we could multiply it out here, but it would be easier to just take the definition of the fact that mu of x is just equal to, or mu of x, p of x is just equal to mu prime of x. So again, mu prime of x is just d dx of mu of x, and mu of x we know is just 1 over x squared. So we can take this and put it back into there. So, and then that's going to let us use the product rule later as well. So d over dx 1 over x squared y equals to mu of x g of x, which is 1 over x squared 3 over x squared. So we can combine those two pretty easily, but at this point we can look at these two factors here and recognize that we can use the product rule. Again, so the product rule is defined as g and the derivative df of x plus f dg of x dg dx is just equal to the derivative with respect to x of the product of both f and g. So combining these two in that way, we're left with just the derivative d dx of our f, which is 1 over x squared, multiplied by our g, which is just y of x, or you just say y. So, and this equals to the product of these two terms, which is just 3 over x to the 4. So, so at this point, you can see now that we have a derivatives here, and a function of y. So we want to get rid of this derivative. So to do that, we can take the integral of both sides. So the integral of d dx of, or multiplied by y over x squared equals to the integral of 3 over x to the 4 dx. So the integral and derivative cancel out, so we're left with just y over x squared here, and this equals to minus 1 over x to the third plus some constant. So at this point you should recognize that we can divide out our integrating factor back. So remember, the integrating factor mu of x was just 1 over x squared. So if we divide the the remaining differential equation by this factor again, we should be left with just a function of y. So dividing this by 1 over x squared, we're left with y equals x squared over x3 plus x squared c. So now we're pretty much done. So we have y the function of x, which is our goal. So y is minus 1 over x plus x squared c. So you can maybe make that look prettier. But yeah, we're pretty much done. So I'm going to upload this video on YouTube and show you guys how to edit it.